All right, so hopefully we've watched the video over position graphs from Flipping Physics, but if we haven't, that's okay. Let's talk about them now. So for these first two up top, and this is the motion diagrams and graphs worksheet, I'll make sure to label it at the top so we know which is which in terms of the attachments on the assignment. These first two, you're given a diagram, and you want to translate that diagram to a graph. So if I start here in the top left, I see some dots, they're spaced out, and there are arrows to the right. So what that means is, if there are arrows to the right, that means the object is moving to the right, which also means that this would be my initial position, and this would be my final position. So how am I going to graph this on a graph? Well, if my initial position is 5, that means at 0 seconds, it's at 5 meters. 1 second later, let's go to the next dot, that's at 7 seconds. Another second later, we're at 9. Another second later, we're at 11, then 13, then 15. And what I can do here is I can make a line. I've already made the graph. I'll make a line that connects these, and I see it as a straight line sloping upward. So before we talk about what we can get from this graph, let's go ahead and do the second one. So I can see this object is moving to the left because of the way the arrows are pointing. That means this dot is my final position. This dot is my initial position. So my initial position, if I label these with their values to help me figure out where it is, that will be at 19 meters to start. 1 second later, now we're at 16 meters. 1 more second later, now we're at 13 meters. Then another second later, we're at 10. Then 7, then 4. And just like the last one, I'll make a line that connects all of these, and I see that line is sloping downward. So in just a second, we'll come up with some notes about things we can get from position graphs, but let's focus on the ones we have right in front of us. So what does this graph tell me? Start with the left. Well, in physics, we're either going to be finding the slope or the area of our graphs. Once we get into different types of graphs, we can have both. That means something. I'll go ahead and tell you for position graphs, area doesn't mean anything. So let's talk about what do we get from the slope. Now to calculate slope, we're not going to worry about any complex formulas. Let's just talk about rise over run. The rise of this graph is from 5 to 15. That is a difference of 10 meters. The run of the graph is 5 seconds. So when I take the slope, that's 10 meters, the rise, over the run of 5 seconds, and I get the slope is 2 meters per second. The units of meters per second tell me that the slope here gives me a velocity. How do I know it's velocity and not speed? Well, let's find the slope of the second graph. The second graph has a rise and a run. The run is 5 seconds. The rise is a negative 15 meters. That's because this graph slopes downward. So I know the slope of this graph would be negative 15 meters over 5 seconds, or a negative 3 meters per second. So now I know this is a velocity because my measurement can pop out negative, which tells me direction. For the sake of time here, let's group this all together. Almost. All right, for the sake of time here, at the bottom, this is the same, just going the opposite direction. I give you the graph. Can you map out the diagram? If we really want to check our work on that, let me know and I'll make a key for that. But let's move on. So let's talk about some things we can get from position time graphs. So first, we can look at the slope. The slope tells us the velocity. Not only can we look at the slope value for the velocity, I can also look at which way the graph is sloped. If the graph is increasing and sloped upward, that means this object is either moving up or right, because those are our positive directions. I would get a positive slope, and so that indicates either up or right, depending on the situation. If it's sloped downward, this object is either moving left or right. So there's a value for the slope that gives me velocity. I can look at which way it's sloped to figure out if it's moving up or right. What did I just say? That's not correct. It's either moving left or down. Yeah, my bad on that one. So the slope gives me a velocity. I can get a number for that. But there's also like a quick way to tell just how fast something is moving compared to something else. The steepness, let me spell it correctly, of the graph can indicate the speed. So steepness is kind of ignoring whether it's sloped up or down. Steepness is just looking at how steep is the line compared to another one. So if I have two graphs, one steeper than the other, I know the steeper graph is moving faster because it's changing more in a certain amount of time, changing its position more than the other graph in the same amount of time. So these are what we can get from position versus time graphs. So let's work on that with the ranking tasks. So this first ranking task, we're supposed to rank the magnitude of the displacement from 0 to 4 seconds. So first, let's figure out what's the displacement for all four of these graphs. Remembering that displacement is final position minus initial position. We may not have to write that out every single time, but that's the good definition and formula to use. So look at A. It starts at 6, it ends at 6. If you start and end at the same position, your displacement is 0 meters. If I look over here at D, it starts and ends at a position of 0. So that is also a displacement of 0 meters. If I look at B, it goes from 2 to 6. So your final is 6, your initial is 2, so that displacement is a positive 4 meters. And then C over here goes from 8 to 0, so your final is 0, but your initial is 8, so you get a displacement of negative 8 meters. So how do I rank these? So I found the displacement. What does this mean by magnitude up here? Magnitude means we ignore negatives. Because remember, negative just means direction, so I'm not caring about the direction, I'm just looking at the number itself. If I do that, what number here is the least out of them all? Well, it's 0, and A and D are both 0. So those are the least. The next least is 4, so that would be B. And then the greatest would be this 8 if I'm ignoring the negative. So then I would put C next in order. So this would be the correct order. If you're doing it virtually, again, you can use a box to put around A and D to indicate they're the same. Or you can just figure out some way to tell me that those are equal to each other. As far as the explanation box here on the right, I'm perfectly fine if that's your explanation, just the equation or definition of what displacement is, because that's what we're using to determine our ranking. Now let's look at the next one. Now instead of displacement, I'm trying to rank the average speed of the object. Well, to rank the average speed, I kind of need to know how to find speed. Speed is distance over time. The time for all these graphs is the same. My time is going to be 4 seconds. So the question is, what is the distance traveled in the graph? Well, for the first one, the distance, it stays at 6 the entire time. So the distance there would be 0 meters. It didn't move. So if the distance is 0, the speed is also 0. In B, the distance was from 2 to 6, so a 4 meters. So if I put 4 in my speed formula up here, 4 divided by 4, that's a speed of 1 meter per second. For C, I went from 8 to 0, so my distance is 8 meters. Notice I did not put the negative on there. I ignore negatives with distance. So 8 divided by 4 would give me a speed of 2 meters per second. And now let's look at D. What is the distance covered in D? Well, first, it goes from 0 to 8. So that's a distance of 8 meters. Then it goes from 8 back to 0. That's another distance of 8 meters. So the total distance here would be 6. Even though the displacement is 0, it still traveled a total of 16 meters. 8 to the right and then 8 to the left. So if I divide 16 by 4, I get a speed of 4 meters per second. So now if I want to rank them based on their average speed, they're actually already in that order. 0, 1, 2, then 4. Now finally, let's look at the last one. This isn't a ranking task, this is evaluating a statement. So a student is shown the position time graphs for 2 objects, and they need to decide which object is moving faster. So this is what the student says. B is faster because it has the steeper slope. Well, if you look back to the notes we just took, I think this is a perfectly acceptable explanation because we said steepness indicates the speed. So B is definitely steeper here, so B is moving faster. What we would like to note is this whole line A is above B. So what this would mean physically is if this was a race, A had a head start, but is moving slower than B. If we kept this graph going, eventually what would happen to these 2 lines? Eventually, they would meet and touch. At that point, B would be passing A in the race. At any point after that, the B line would be above the A line, and so B would be ahead of A if the race went on longer than the graph showed. But for this, there's nothing wrong with the statement. We can just write correct. Last thing I want to talk about is how do I read graphs that have multiple sections? So all the graphs before, they've had one section, well, aside from some of the ranking tasks. But what does this physically mean for us? Because my gut feeling is when I look at this graph and I see all these sections, I want to picture something moving uphill, like up a mountain and then back down a mountain. But that's not actually what's happening at all here. This object is moving either left or right. So let's talk about that. Let's look at section 1. Section 1 starts at 0 and then ends up at 20. So section 1 would be moving from here to here. There's 1. Section 2, its position is 20 to start and 20 to end, and it's a flat line. It doesn't move. So section 2, it just stays at 20 meters. It stops for 2 seconds. What about section 3? Section 3 goes from 20 to 40. So 3 moves to the right from 20 to 40. And then what happens in section 4? Section 4 goes back to 20. So notice any of these upper slope sections, it moved to the right in a positive direction. In this negative slope section, it was moving to the left because the slope indicated it changed direction. I will say, the last thing, how does the speed of section 4 compare to the speed of section 3? What goes in the middle here? Well, the speed of section 4 is actually greater than the speed of 3. And what's my explanation? 4 is steeper than 3. Again, doesn't matter that 4 is sloped in the opposite direction. All I care about is that 4 is steeper than 3. So it must be moving faster, even though it's in a different direction than 3 is moving. So I hope this is helpful. Remind me with any questions, and have a great day.